Hello students, I welcome you all in today's video. In today's video, we are going to talk about Newton's laws of motion, right? And in Newton's laws of motion, we are taking a special topic which is very important for NEET and JEE. And the topic is constrained motion, right? What is happening in constrained motion? Constrained motion means the motion of one object is restricted to the motion of other object, right? So in this particular topic, we are going to talk about again a particular thing which is wedge constraint, which is the important part of NEET and JEE syllabus, right? So let us see what is this concept. Actually, we are going to understand this concept with the help of a question, right? So let us see what's the question. Now, the question we have is a rod moves vertically downward on the surface of the wedge as shown in the figure. Find the relation between the velocity of the rod and that of the wedge at any instant, right? So what is happening here that we have a rod as shown in the figure and we have a wedge, right? The rod is fixed between two vertical supports. That means the rod cannot move horizontally. The rod can either come down or it can go up, right? But when the rod is coming down, the wedge is going back, right? So here the motion of the wedge is basically related to the motion of the motion of the rod. That means when the rod is coming down, the wedge has to move backward. Okay, so this is the question we have. Now let us talk about the concept that we are going to use to solve this kind of question. See, if you talk about the question, especially the wedge constraint, we have a concept that says if you talk about the motion of the rod and the wedge, then motion of the rod and the wedge along the perpendicular to the contact surface, that has to be same. That means if I draw a line here, then what is happening? If I'm going to draw a line, suppose this is the line we have, right? Then motion of the rod along this line and the motion of the wedge along that line has to be same. See, what is happening if the component of the velocity of rod and component of the velocity of wedge along that line is not same? See, in that case, the contact will lose, or the rod will break the wedge and it will embed it into it, right? So the wedge is placed on a frictionless floor. There is no friction here, right? The wedge is going back and the rod is coming down. So we have to establish a relation between the velocity of rod and the velocity of wedge, right? So let us see what's the case. As I told you, the concept says the velocity of the rod and the wedge along this perpendicular line has to be same, right? So we have some options in the question also. These are the options. From here we have to choose the correct option. And the concept that I told you, the motion of the rod and the wedge along this yellow line has to be same. Means along the line which is perpendicular to this inclined plane has to be same, right? So let us do the component of the velocities and let us equate that. We will get the answer. Actually, to solve this question, we have a lot of methods, right? But this is the easiest method. This is the easiest method which is giving you answer very fast. That is why this is necessary to learn if you are a NEET or a JEE aspirant, right? So let us take the component of the velocities. Now this component is VA, that is given to us, and this component means not component, the velocity is given to us is VB. Now we will do the component of VA and VB along this perpendicular line. For that, what we need the angle, right? In physics, there's a concept that says if you have angle theta between two lines, then angle between their perpendiculars will also be theta, and angle between their one perpendicular and one parallel will be 90 minus theta. So if you talk about VA line is perpendicular to this baseline, okay? And if you talk about this this line, which is the perpendicular line to the contact surface, this line is perpendicular to the inclined plane. So if this angle is theta, then this angle has to be theta only, right? and this angle will be in that case 90 minus theta. So now we can do the component easily. Let us do the component. Component of VA along this perpendicular line is what? That is going to be VA cos theta. So this is VA cos theta we have, right? And the component of VB along this perpendicular line is what? VB cos 90 minus theta. That is nothing but VB sin theta. We are not talking about the other component which are perpendicular to VA cos theta and VB sin theta. We are just considering those components which are only parallel to this line. That means towards this line. That means along this line, right? So let us equate this and we will get the answer. So here VA cos theta has to be equal to VB sin theta, right? So what can I say about VB? So VB sin theta, by if I shift that side, it will be VB cos theta by VB sin theta by cos theta. That is basically VA, right? So what is VA then? VA is going to be VB tan theta. So this is going to be the correct answer, right? So which option is true? Option C is the correct answer. So dear friends, always remember the concept that the motion of the wedge or this rod along the perpendicular to the contact surface line has to be same. If that is not same, in that case, either the contact will lose or the rod will break this wedge, right? Since this situation, this rod is coming down and the wedge is going back smoothly, that is why we are taking the component same. And this is the relation of velocity, right? But if someone asks you that what is the relation of acceleration? Actually, if you have the relation of velocity, you can differentiate that to get the relation of acceleration. And if you will do that, you will get acceleration of A block is going to be acceleration of B wedge times tan theta. That means acceleration of the rod is equal to acceleration of the wedge times tan theta, right? So I hope this concept is clear to you. Thank you.